Good morning, class. We are looking at the second part of section 3.5, implicit differentiation and related rates. And this session is being recorded. Again, if there is any issue with privacy, make sure your audio video is muted. Do not participate if I ask you. You can even change your name or initials. Implicit differentiation. Basically, the idea is when X and Y are on the same side and you want to differentiate, you have a choice. You can explicitly solve for Y and differentiate, or just differentiate it as is, known as implicit differentiation. However, the advantage of the implicit differentiation is that it works even when you cannot solve for Y explicitly, as it is the case in many examples that we have done. Okay, so for example, in this case, and I'm going to go over the very first step only because we have covered this. X cubed gives you 3x squared, and y cubed gives you 3y squared dy dx. Because y, okay, when x is the independent variable, the derivative of x is 1, the derivative of y is y prime or dy dx. Remember that. That's the reason. So the right side 6x is being multiplied by y. So 6x gives you 6 times y. Y gives you dy dx times 6x. And again, at this point, you're done with calculus. Use your algebraic techniques to finish the job. Here, you can put a raised dot in between 4x squared and y, and you use the product rule. So 4x squared gives us 8x times y. Y gives us dy dx times 4x squared. Plus 4y, y prime or dy dx. The right side is a number results in 0. You go through the process of your algebraic steps, you solve. There's a lot of algebra involved, class, but we are interested in calculus part. The assumption is you have no problem with the algebraic steps. 4x squared gives you 8x plus 6y prime or dy dx plus 2y y prime. E is a number, gives you 0. Again, a raised dot between x and e to the power of y tells you that you're using the product rule. X gives you 1 times e to the power of y. E to the power of y gives you itself times y prime, and by the product rule times x, plus 6y squared y prime equals 3. Again, you go through your algebraic steps to finish the job. We want to find an equation of a tangent line. We put a raised dot in between and we find the derivative function and then the slope. X squared gives you 2x times y squared, and y squared gives you 2y y prime times x squared. The right side is 0 because it's a number. You finish the job and you plug in the pair, that becomes the slope, and then y minus y1 equals m times x minus x of 1, the point slope, and you're done. We looked at the concept of a related rate. In the case of related rates, we are interested in finding a rate of change for a specific quantity where other quantity maybe is known, and therefore you find that equation that relates the quantities, then you differentiate and using the chain rule. Remember, in the case of a related rates, the only independent variable is t. In which case, You differentiate, and everything is a dependent variable except t, and you come up with the answer. So with that being the case, please understand that even x gives you dx dt when you differentiate, and y gives you dy dt, and I don't know, maybe r gives you dr dt, m gives you dm dt, the point being every variable is dependent. So in this example, which was a warm-up example, and we did, okay, air is being pumped into a spherical balloon so that the volume is increasing at a rate of 100 cubic centimeters per second. We want to know how fast the radius is increasing when the diameter is 50. So we need a piece of information from geometry. This is the explanation again verbally. We need to know the volume. So the volume of a sphere has the formula 4/3 pi r cubed. As long as we know that, we are practically done. So we know this one. So what is given is dv dt is 100 cubic centimeters per second. And we are going to find dr dt when d equals 50 and r equals half of that, or 25. So this is the given symbolically. If we can write this, then it becomes a piece of cake. You differentiate both sides with respect to t. So v becomes dv dt. 4/3 pi doesn't go away, it's just a number. You just differentiate r cubed, which is 3r squared dr dt. And that's the concept of a chain rule, everybody. This 3 cancels out this 3, and you get 4 pi r squared dr dt. The rest is history. You plug in, you come up with the answer. Okay, everyone? A small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at a rate of 3/2 feet per second. We want to find the rate at which the area is changing at a specific point when the radius is 4 feet. Again, we need this piece of information from geometry. Area, pi r squared. Diameter, 2 times the radius. Circumference, 2 pi r. We need the first one. We are interested in the area, but I'm giving you the information about this circle. So what is given is that the radius is increasing. So dr dt is given. So what are we looking for? dA dt. When? When r, or the radius, is 4 feet. So if you write this, again, practically you're done, because the rest should be easy. This translation is the most important part, and therefore we are going to differentiate this, which becomes dA dt is pi times 2r dr dt, or 2 pi r dr dt. Just plug in and you are done. We had covered this. Let's go to the new stuff, everybody. We want to find dy dt for this equation, where the x dt is given as 10, x is 4, and y is negative 2. Now, again, the very first thing I want to mention to everybody is that the independent variable here, from here we can find out the independent variable is t, which means if you're differentiating x, you get dx dt. If you're differentiating y, you get dy dt. And that's extremely important, everybody. We should know what we are getting ourselves into. And so the derivative of x is no longer 1. So having said that, let's do this term by term. 4x, remember x, dx dt, so 4 dx dt, plus 3 times 4, 12, y cubed dy dt, equals x squared. That gives us 2x dx dt. Okay. Now, we have 2 choices, class. I want to make sure everybody understands what we are doing here. If you are evaluating dy dt, all you have to do, plug in right now. You're done, by the way, with calculus. You can plug in and evaluate. I'll show you in a moment. And that's fine, absolutely fine. But for practice, I'm going to actually solve for dy dt. And again, you don't have to, but it's a good practice to solve for dy dt. I'm going to move the 4 dx dt. Okay, so I'm going to move this, everybody, and it becomes negative on the other side. So I'm going to solve for dy dt, so I'm going to get rid of 12y cubed. How? I'm going to divide both sides by 12y cubed. Okay, so I'm going to divide both sides by 12y cubed. It's that simple. So when we do that, we end up with dy dt. Now, there is a common factor of 2 we can drop, because the right side we can take the 2 out, and the left side 12y cubed. Now I can drop the 12 and change it to 6. And now I can plug in the values. Okay, I can plug in the values. And of course, you know how to do that. But let's assume we didn't do that. Let's assume we are just plugging in right here. So plug in all the numbers. So 4 times dx dt, which is 10, plus 12 y cubed, that means negative 2 cubed, times dy dt, which is missing, 2 times x, which is 4, times dx dt, which is 10. Okay, so what happens is, of course, this is class negative 8. And so you're looking at 40 plus 12 times negative 8 minus 96 dy dt. 2 times 4 times 10 is 80. We are going to move the 40 and subtract from 80. So the right side is 40. And we divide by negative 96. Okay. And we drop a common factor of 8. And we end up with negative 5 over 12 as the final answer, everybody. It's that simple. I hope everybody is okay with that. So we can move on. Okay, so a quick recap. After you get here, you have a choice. Solve for dy dt and now plug it in here. If you go this route, you should plug it into here. I want you to know that. Or from the get-go, just plug in after you differentiate. Okay, everyone? Either way is fine. As long as we know what we are doing, any of those will do the job for us, and that's good enough. We are ready for the next one. Again, as we read the question, the thing I want you to notice is this, dx dt. So right away, the moment we see that t is the independent variable, okay? So pay attention to what the question is asking. Everything is given, dx dt is missing. Let's differentiate the equation with respect to t. Starting with this. So 3 times x gives us dx dt plus y. This is a product rule. Y gives us dy dt times e to the power of x. And then e to the power of x gives us e to the power of x times dx dt by the product rule times y. And the right side is a number which results in 0. And now we are done. So we have a couple of choices. We can plug in, or we can solve for the missing dx dt. I'm going to do both again just for practice. You don't have to do both ways. Obviously, one is good enough. Okay, one is good enough. For practice, I'm going to do both. Okay, class. So here's what's going to happen. If I plug in just the way it's given, and I choose to do that first, that's just to show you don't have to solve. So dx dt, okay, is missing. So 3 times dx dt plus dy dt, I'm going to replace it with -8. E to the power of x, I'm going to replace the x with 0, the same thing here. And then the x dt is missing, and I'm going to replace the y with -1. Obviously, e to the power of 0 is simply 1. So what we are looking at is 3 dx dt minus 8 minus dx dt. Right, everybody? So that means we really have 2 dx dt. And then minus 8 moves and it becomes positive 8. We divide that by 2 and you have the answer. Okay, so you have the answer. Very straightforward, class. Okay, very straightforward. This is when we plug in, we just plug in. But if we were to solve for the missing dx dt, what happens now is that anything involving dx dt remains. This guy we have to move. So take a look. This one moves, becomes negative, and this one we write it as y e to the power of x dx dt. When you factor the dx dt, on the left side you have 3 plus y e to the power of x. So we are factoring now. We are going to divide both sides by the parentheses. When you divide by the parentheses, it goes away on the left side and it becomes the denominator of the right side. And now you can plug in and you get the same answer for. Now you can plug in and it will give you the same answer. Okay, class? Okay. We're going to get the next one. Same situation. The moment I see dy dt, I realize, okay, the independent variable is t. That's important. Just pay attention to that. Independent variable is t. We want to differentiate this. Okay. So we want to differentiate this, where this is the given. So what is our first step? Differentiate the left side accordingly. So if you are differentiating the parentheses to the power of 4, 4 sits in front and becomes a coefficient. You write the same parentheses to the power of 3. By the chain rule, the derivative of the inside, which is 5 dx dt plus dy dt. Minus x gives us minus dx dt, and the right side is a number, gives us 2. Done with calculus. I'm not going to do both ways. I'm going to just plug in, and I highly recommend for practice, you guys do the solving for dy dt just for practice, okay, making sure you have no problem with the algebraic techniques. So we are going to replace the x with 2, class, so 4 times 5 times 2, so we're going to replace this with 2. We're going to replace this with -9, okay, and then 5, we're going to replace dx dt with 3, all right, dy dt is missing, and then minus dx dt. So what happens is very simple. 5 times 2, class, so let's just actually, so this is 5. That's how we get to the 10, okay? And then we add -9, okay? So what happens is that this changes to 1, and 1 cubed is the same as 1. So when we rewrite this, everybody, 4 remains. This changes to 1, so it has no effect, just 4. 5 times 3 is 15. So 4 times 15 plus dy dt minus 3. Okay. So if we apply the 4, we get 60 plus 4 dy dt minus 3. And 60 and -3, they add up to 57. and it moves to the other side, becomes negative 57. So in case class, let's just write 60 and negative 3, we can change it to 57, okay? Then you move the 57 to the right side, it results in negative 57. Divide both sides by 4, and you're done. Divide both sides by 4, and you're done. That means dy dt. So this is class. I should write dy dt is equal to that, okay? So it's dy dt, which is minus 57 over 4. dy dt is minus 57 over 4 as the final answer for this question. Okay, pretty good. I'm hoping that everybody pays attention to your independent variables so we don't make a mistake. Here's the next one. Falling sand is forming a cone-shaped pile. So pay attention to cone-shaped. The volume of a cone is increasing at a rate of 54 pi cubic inches per minute. What gives it away as the rate class is per minute, per unit of time. That means whatever the unit may be, in this case, the unit of time is in minutes. The height of the cone is twice the radius. So that's another piece of information I want to highlight, let's say with the red. So the height is twice the radius. That's another piece of information. So we are reading it very slowly, so because we want to translate this. We want to find the rate at which the radius changes at a specific time when we know the radius is given as 6 inches. So we are going to translate this, and then practically we are done. Number one, I hope everybody remembers the shape of a cone. And more importantly, we are looking at the volume of a cone that we want to relate it to its radius. Therefore, we should know the volume of a cone is 1/3 pi r squared h. So that's the formula you must know. Okay. So that's good. Now what comes next? Let's write everything else. So this is a piece of information from geometry. The volume of the cone is increasing at the rate of 54 pi cubic inches per minute. The moment you hear a rate, that means dV dt. Okay. dV dt is equal to this, 54 pi cubic inches per minute. The height of the cone is twice the radius, so h is equal to 2r. Okay. Find the rate at which the radius changes. That means dr dt when r is 6. So take a look. Here's the formula for the volume. dV dt is given. H is 2r. dr dt is missing. And we want to find that when r is 6 inches. So again, this is the translation. I can't emphasize this enough. We are looking at word problems, applications, and translation is the key. If we do this right, we have an easy time finishing it up. Okay, we want to move on to the next step and find the derivative or the dV/dt. Before we move on, we notice that here's the variables. So V is a variable, R is a variable, H is a variable. So V is a function of R and H, and all of them are dependent, and the only independent variable is T. So if you were to differentiate it just the way it is, you are looking at R squared times H, which requires, you know, the product rule on those two variables. However, H is 2R. Because I want dr dt, I'm going to replace the H with 2R. If the question was asking for dh dt, okay, then I'm going to replace the r here. How? R is h over 2. Do you follow what I'm saying? So we're going to stick with h equals to r and replace it. When we replace the h with 2r, it becomes 2/3 pi r cubed. Now we have only one variable, so let's differentiate with respect to time. dv dt is 2/3 pi. Remember, I highly recommend you just write it the way it is because it's a multiplier, and then differentiate r cubed. This gives us 3r squared dr dt. 3r squared dr dt. And number 3 cancels out the denominator, and this is simplified version of dv dt, 2 pi r squared dr dt. So all we have to do is set this dv dt equals to this number and find the missing dr dt. So let's plug in, meaning replace the dv dt with 54 pi cubic inches per minute, 2 pi, keep it, r squared, replace the r with 6. So this one, by the way, class, remember this becomes 6 squared, which is 36. So what happens, 2 times 36 gives us 72. Okay, everybody? 7. That's how we get to 72 pi. So replace the r, replace the dv dt, and now you are solving for dr dt. So if you're solving for dr dt, what do? You are going to divide both sides by 72 pi. Let me write that for you. So we are going to divide this by 72 pi to get to dr dt. We do exactly the same thing here. And of course, the pi drops out. We get 54 over 72. Both of them are divisible by 18, 3 over 4. If you don't see the big picture, it's okay. Divide both of them by 9, okay? If you divide both numbers by 9, you get 6 over 8, and then 6 over 8 equals 3/4, okay? Units. I want to discuss the units. I want to make sure we are comfortable with the units. The units of the volume, okay, cubic inches per minute. The units for the radius, okay, inches per minute. The units of the numerator over the units of the denominator. And as I mentioned, how do you know it works that way? Because really, when you plug in the VDT, you have to put cubic inches per minute. And for R, you should put 6 inches to the second power. So 36 inch squared. That's how you get to the proper units also. When you do the math, whatever we do to units, we do also, whatever we do to numbers, we also do to units, and it works out perfect, class. I can't emphasize this enough, okay? So whatever we do to numbers, we do to units for it to make sure it works properly. It works properly. So we are ready to move on. Here's the next question, everybody. A 20-foot ladder leans against a building. The base slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. Anytime you have an application word problem, you really have to come up with a setting. If you can draw the setting, it really helps come up with the answer. So here's the setting. So this is a ladder. It's leaning against this wall, and this starts moving this way, slipping away, going this way. And at some point, it looks like this is slipping away, and this is the height is decreasing. It's coming down. The base is moving away. It's going down like that. So let's go back and reread again. A 20-foot ladder. Notice this is fixed, this is fixed at 20 feet. The resulting shape, of course, is a right triangle. So what's happening, the base of the ladder slips away at a rate of 2 feet per minute. So if this is x, then this is dx dt, 2 feet per minute. If this is y represents the height, find the rate of change of the height. That means dy dt is missing, everybody. Dy dt is missing. And we want to know what that is when x is precisely equal to 12 feet. Okay, now, what is it that relates x and y? I hope you see the Pythagorean theorem. A squared plus b squared equals c squared. And for us is x squared plus y squared equals the fixed number 20 squared. So dx dt is 2 feet per minute. X squared plus y squared is 20 squared. Dy dt is missing when x is 12. So what we are looking at is a simple case of, again, algebra, geometry, you name it. You should know Pythagorean theorem. Okay. So with that being the case, all we have to do, know this formula and differentiate it. Let's differentiate this with respect to t. 2x dx dt plus 2y dy dt equals any number results in 0. So 2x dx dt plus 2y dy dt, and the right side gives you 0. Now, if we were to plug in, we notice this. 2 times x is given. Dx dt is what we are having as 2 feet, so far so good, plus 2 times y dy dt. We want to find dy dt, but we don't even have y. How do we find y? Well, here's the Pythagorean theorem, and it says x squared plus y squared is 20 squared. If x is 12, I can find y using that. So let's find the y value. X squared plus y squared is 20 squared. And I'm assuming everybody can do this simple math. Okay. Subtract 12 squared, which is 144, from 20 squared, which is 400. Take a root and you get 16 feet. Okay, just in case. Those numbers are pretty straightforward. This is 144. This is 400. Okay, class. And so y squared is 256, and you do the math, you get 16. All right, now we have everything. We're going to plug in. So when we plug in, 2 times x is 12, dx dt is 2. This gives us 48, plus 2 times 16 is 32. And so we move the 48, we get 32 dy dt is negative 48, everybody. Divide both sides by 32. Okay. Drop the common factor of 16, you get negative 3/2 feet per minute. What I want to explain here, and that's extremely important, is to notice okay, I'll do that shortly. When x moves to the right, x is increasing, so dx dt is positive. When y comes down, dy dt is decreasing, and that's why it's negative. So even the sign works. Now, I want to look at the same question. What I want you to notice, as things change here, class, as we move this way, not only x and y are changing, also this angle, theta, the angle that it makes with the floor, and the angle with the wall. Both of them are missing. So in this example, we want to look at the angle between the ladder and the ground. So we are going to look at the same question, everybody. Same question. Everything is the same, but this time we are looking at theta. Okay, we are repeating the same question. So it's important to understand a couple of things. Again, we have everything from the previous page and not a problem. But in this question, it says find the rate of change of the angle between the ladder and the ground. So we want d theta dt, d theta dt. So you want to relate what's given. So a couple of things I want to write for you. I hope you remember that sine is the opposite, okay, over the hypotenuse, which is fixed at 20. And cosine is the adjacent, which is x over the hypotenuse, which is 20. Okay. Now, the given is being repeated, class. There is nothing brand new. Dx dt is 2 feet per minute. X squared plus y squared is 20 squared is one piece of information we need. From the previous page, we've done this work. D theta dt we are looking for, and we have to use one of those formulas. Now, I recommend you always use what's given. You know that x is given. Although we also have y from the previous page. Remember, we calculated it at y equals 16. You can use that, but don't take a chance. Always use the given to be on the safe side, because maybe we made a mistake. Hopefully we haven't, but in case, so always use the given. So we're going to use this one, and we're going to differentiate both sides. Cosine theta is x over 20. So we're going to use this one. Cosine, the derivative is negative sine d theta dt. And the right side, class, if it helps, rewrite it as 1 over 20 times x. So it's 1 over 20 times dx dt. And so we have everything. Sine theta, we have to calculate the sine theta using this formula. And y, from the previous page, we know it's 16. So I'm going to remind you that y is 16. This is previous page, class. And now we are going to replace the sine with y over 20. Now to solve this, here's a very easy way. I hope you remember one way to solve an equation involving fractions where the denominators are identical on both sides. You can drop it. So you can say negative 16 on the left side, d theta is positive 2, divide by negative 16, and you get negative 1 over 8. What I want to discuss is the units. In calculus, the units of angles are always radians, unless otherwise mentioned, always. So minus 1 over 8, radians per minute, radians per minute. I want to look at the last question, everybody. I want to look at the last question. This is a question we have already seen, okay? There's a slight difference, and that's why I am looking at it. A spherical balloon is deflating or losing 8 cubic centimeters of air per minute. At the moment when the radius is 20 centimeters, how fast is the radius decreasing? Again, we did something similar to that. And the hint is volume is 4/3 pi r cubed. You should know that. Why am I using this? Because I want you to pay attention to this. Where it says deflating or losing, that means you have to use a negative sign. That's the only thing, class, that really distinguishes this question from the warm-up example. Of course, the numbers might be different, but the only reason I want you to pay attention to this is the VDT, but because it says losing air or deflating, it's minus. That's the only thing. Of course, that's the case, and the radius is 20. Now we are going to differentiate this. We already done that. I hope you remember the 4 pi r squared dr dt from that question. We are going to replace the r with 20, And we are going to replace the dV/dt with -8. And that gives us 400 here. And so 8 over 4 pi times 400. We can drop the 4 and 8. This becomes 2. And we can drop, let me use a different color. This one to 1, this one to 200. This is the precise answer. Don't forget the negative sign remains. And of course now, a rough estimate gives us this answer.